Alright, this is topic 67. We're going to integrate e to the x and the natural log. So again, we're integrating Euler's number and the natural log. So let's start off with this. What is the antiderivative of 1 over x? Okay, well, to answer that, we can think about it backwards. We can think about the derivative of the natural log of x, as you well know, is 1 over x. And if that's so, then the derivative of 1 over x, the antiderivative of 1 over x, then that has to be the natural log of x plus c. Again, if the derivative of natural log of x, that is 1 over x, then the antiderivative of 1 over x dx is going to be the natural log of x plus c. So for all x is greater than 0, remember that, and I don't know if you remember this or not, you cannot have the natural log of a negative and you cannot do the natural log of 0, right? Because there's a vertical asymptote right on the y-axis. So also the derivative of the natural log of negative x is equal to 1 over negative x times the derivative of x, which is going to be negative 1. Okay, so again, the derivative of natural log of negative x is equal to 1 over negative x times negative 1. Well, that's going to give you also 1 over x. Alright, so notice that the antiderivative of 1 over x dx can also be the natural log of negative x plus c for all x's that are less than 0. So notice that you get the same thing. Alright, you get the same thing no matter if you take the antiderivative of this or this, you can get both answers. Both answers are actually legitimate. So therefore, when you take the antiderivative of 1 over x dx, you can say that that's equal to the natural log of the absolute value of x plus c. Okay? So that's how that works. So again, this is how the antiderivative of 1 over x dx is equal to the natural log of the absolute value of x plus c. Alright, if you do the same idea for e to the x, notice that the derivative of e to the x is e to the x, so therefore the antiderivative of e to the x is e to the x plus c. Alright, so let's do an example and hopefully that'll make more sense as we're going. Alright, so we're still using u substitution. So if I let u be equal to negative x squared, right, then du is going to be equal to negative 2x dx. Now if I divide both sides by negative 2, notice that again I'm doing that because if you look at it, I have an x here. I don't have a negative 2x here, so I'm going to divide both sides by a negative 2. And that is going to give me the same thing as e to the u du over negative 2, and we can simplify that by pulling out this constant all the way out of the integral, negative 1/2 eu du. Right, so the antiderivative of e to u du is just e to the u plus c, so now we have negative 1/2 e to the u plus c. Okay, now if we distribute that 1/2, we will have negative 1/2 e to the u plus a constant. Now I know that you're thinking, well, how come this is not negative 1/2 c? Well, it can be, but that's still a constant. So even if I grab this constant and I multiply it times another constant, that's still going to give me some other type of constant. So I can actually leave this like that. Okay? So finally, the last step, if you have been doing this, this would be the easy part. You're going to go ahead and replace u with negative x squared. So my final answer is going to be negative 1/2 e to the negative x squared plus c. So this is my answer. Okay, so that is that. So when you have a Euler's number or a e function like that, that's actually a whole lot faster. So let's go to the back now. Same thing, we're still using substitution. Now in this one right here, notice that this can be a little bit of confusing notation for some. Alright, this is the same thing as having the natural log of z square. Alright, so that's the same thing. This is not the natural log of z squared. That's not the same thing. Alright, so make sure you don't get those two confused. So if I notice that this right here, this kind of fits the description that I used in 65. I have a function within a function. Alright, so we have the natural log. If I let u be the natural log of z, notice that this is the inside of that. And du, well, the derivative of natural log of z is 1 over z dz, right? And notice that I have everything I need. I actually don't have to do anything else besides this. Alright, du, in case you can't tell, so in case you cannot tell, this is du right here, which is going to be all of this stuff. Same thing. Alright. So now this is going to be equal to the integral of u squared du. Okay, so that's that. So I just have to integrate that. This is going to be equal to u cubed over 3 plus c. And that's basically almost it, except for now I have to replace the u. So I'm going to substitute back the natural log of z. So the natural log of c cubed over 3 plus c. Alright, so that's the answer for that one. Alright, let's look at example number 3. Now again, make sure you choose your u carefully. And you'll be able to tell, so if you make a mistake, it's fine. Just try to make sure that you are going to get to an answer. So on this one right here, one of the things that I can pick, and this is not necessarily the only thing you can pick, but I can pick this as x plus e to the x, and that's going to be my u. Therefore, my du, or my derivative of x is 1, the derivative of e to the x is e to the x dx. Right, so that's what I have right now. So this is what I have right now, so therefore notice that I have everything I need on this one. Easy example again. So this is going to be equal to 1 over u to the 1/2 power du. Okay? So, well, we're going to have to integrate that. So let's make sure and put this as a negative exponent first. And now I'm going to integrate that. So this is going to be equal to 2u to the 1/2 power plus c. Now I'm going to replace back that u with the x plus e to the x. So this is going to be equal to 2x plus e to the x plus c. Right, so that is it. That's it right there. Okay, good. And I guess I'm saying good for myself because nobody's here. I'm doing good. All right then. Last one. So on this one right here, let's see. If I make u be equal to 1 plus 3t squared, and I make du equal to 6t dt, notice that I almost have everything I need. I have an extra 6 here. I don't want to have that 6 because there's not a 6 on here. So I'm going to divide by 6. Divide this by 6. So this right here is going to be equal to 1 over u times du over 6. Okay? Which I can then rewrite like this. Please notice that if you were to rewrite this as a negative exponent, that would not work out because when you add 1, that would give you u to the 0. Okay, so hopefully you see this when you see this right here, that should make you think of the derivative of the natural log. So this is actually going to be equal to 1/6 the natural log. And I can write u, but let's go ahead and write, well, let me not skip ahead, I suppose. Plus c here, natural log of absolute value of u plus c. Okay, so this is going to, by the way, that's a u. I know I did a bad job on that one. We got 1/6 natural log of 1 plus 3t squared, the natural log of the absolute value of 1 plus 3t squared plus c. Now, be careful, this is the answer. But if you have a multiple choice on an exam, they could actually write this one like this. Because no matter what you plug in into this one, that's always going to give you a positive value. So no matter what you write on this one, this is going to give you a positive value. Notice again that the natural log has to be a positive value, right? More than 0. So again, no matter what you plug in here, it'll always be positive. So this would actually work out too. Okay, so I'm going to write this so maybe you'll remember it. So might be the answer. Right answer on multiple choice test since 1 plus 3t squared would never be negative. Alright guys, that's it. This is a short one. Hope you're doing well. If you got any questions, please make sure and ask me during class, okay? See you next time.